Here's a 3 by 3 system of equations, and in this particular example, I'm just giving you a heads up that it is going to have one solution. So what we're going to do is we're going to look at the three variables, the x and the y and the z, and look at to see which one sort of logically makes sense to eliminate, the x's, the y's, or the z's. And as I look at the coefficients in front of each one, I can see that all the y's are multiples of 4. So that to me is going to make more sense. It really doesn't matter if a lot of people like to just automatically eliminate the x's or like to eliminate the z's. But I kind of like to evaluate each one and see which ones are sort of multiples of each other. So in this example, I'm going to eliminate the y's. So what we're going to do is I can only work with two equations at a time. So I'm going to work with the first two equations. Just the first two. I'm going to ignore the third one for now. Okay, so if I look at the first two equations, I can eliminate the y's by turning this 1y into a negative 2y, or no, positive 2y, right? Because I already have a negative 2y. So the way that I'm going to do that is I'm going to multiply just the first equation by a positive 2. And when I do that and I distribute that amongst everything in the top equation, I get 4x plus 2y minus 2z equals 10. Now my second equation did not change, so I'm just going to rewrite that down here. So minus 2z equals 4. So the second equation, notice, did not change. Sometimes in order to eliminate a variable, it's necessary to multiply both equations by a number. But in this case, we got lucky and we could just eliminate by multiplying by 1. So now you can see that the y's cancel, 2y minus 2y, because we're going to add straight down, right? We're adding straight down. So when we do that, I'm going to end up with 5x minus 4z equals 14. So what I'm going to do now is I'm going to just hold this equation off to the side, okay? So over on the side, I'm going to write 5x minus 4z equals 14. So now the second step is to take the second two equations. So now we're going to go back to the second two equations, these two equations, and we're going to do the same thing. We're going to repeat the same process. In this case, I'm going to ignore the top equation and just work with the second and third equations. So now the important thing is that I have to eliminate the same variable. I can't change my mind and now start to eliminating the x's or eliminating the z's. I have to stick with the y's. Once you start eliminating one variable, you have to stick with it. So how do I eliminate my y's with the second two variables? Or second two equations? Well, if I multiply this middle equation by positive 2, that should eliminate the y's for us. So what I'm going to do is I'm going to multiply the second equation by positive 2. And when I do that, we get 2x minus 4y minus 4z equals 8. And then the third equation did not change at all, right? So I'm just going to rewrite it. I'm not changing anything. Again, sometimes it's necessary to multiply both equations by a number so that things eliminate. So now we can see that the 4y's cancel, the negative 4y plus 4y cancels, and I end up with 5x minus z equals 11. Okay, so now what I'm going to do is I'm going to put that equation. So this equation went up here, and now this one is going to go up here. So I have 5x minus z equals 11. Actually, let me get rid of this. It's going to get in my way. These little arrows. Okay, so now this should be very nice. Now we're kind of home free because now I have a 2 by 2 equation, right? This is just a 2 by 2 equation. I've got two equations and two variables. So now you guys should know what to do to eliminate one of those variables again. So now I am going to choose to, because I already have the same number out here and they're both positive, I'm going to multiply maybe the second equation, or I could have done the first one, it really doesn't matter, by negative 1. So my top equation doesn't change, so I have 5x minus 4z equals 14, and negative 5x plus z equals negative 11. So now when I combine like terms, the x's cancel, and I end up with negative 3z equals positive 3, so z equals negative 1. So we have just solved for one variable. So I'm going to put that up here in the upper right-hand corner. So I know I'm looking for x, y, and z, so I'm going to put the -1 in the z position, right? That's the last variable. Make sure you put them in alphabetical order. So now what I'm going to do is I'm going to take this z of -1 and I'm going to plug it back into one of these two equations. Don't go back into the original set of equations because then you're going to end up with two variables. So I can go back into one of these two equations over here and I'm going to get 5x plus 4, right? -4 times -1 is plus 4 equals 14. So 5x equals 10 and x equals +2. So we just solved for our x variable. Okay, so I'm going to put that in my bucket up top. So now we have the x and the z term, and lastly we need to solve for the y term. So I'm going to take both of these now. I'm going to take the z equal to -1 and plug it into this first equation, and I'm going to take x equal to +2 and plug it into the first equation. Ooh, and I have like no room to write. So let's, I'm just going to squeeze this in way down here, sorry you guys. So I'm going to have 4 plus y, because 4 it was 2 times 2, right? Plus y, and then minus -1 is going to be +1 equals 5. So can you see that this is going to be 5 plus y equals 5? So y has to equal 0. And that is my third variable. And it is a good habit to get into to go through and check all these. If you think x, y, and z are 2, 0, -1, we certainly could plug these into the original equation. I'm not going to take time to do that right now, but you really should do that, especially on a test or something. Just plug each of them in and see if you're getting the numbers on the right-hand side.